Hello students, so let's try to solve one very beautiful problem from IIT JAM 2025, and it is given that two masses m1 and m2 are connected through a massless spring of a spring constant k, which is shown in figure. The mass m1 is at the rest against the wall, so m1 is rest against the wall and both m1 and m2 are on the frictionless surface, so this surface is frictionless. Now it is given that mass m2 is pushed towards m1, so it is just going to push towards m1 by a distance x from its equilibrium. So that will be that x distance it is just going to push from the equilibrium position and then released. After m1 leaves the wall, just m1 is just going to leave the wall, what will be speed of center of mass? So this is a very interesting question and let's try to go for this. So first of all, this is a completely conservative system, okay. So center of mass will have always constant momentum. So whenever you have conservative system, the center of mass will have constant momentum. So what will happen just before it is going to leave, when it is going to push this x distance, we can write the expression of center of mass. So let us assume this spring has length L, that is at the equilibrium. So what will be center of mass? So when we are going to write the center of mass, so xcm is equal to, that value is equal to m1 into 0. I can assume this is my 0 coordinate, and plus we have m2 and the length I can assume for this spring constant is L minus x, and that value is equal to m1 plus m2. So this is center of mass when we are just pushing this particular mass m2 towards this one. And if we want to calculate the center of mass, the speed of center of mass, then obviously xcm dot is equal to minus m2 upon m1 plus m2 x dot. So this will be your speed of center of mass. Now the whole thing is that how we will calculate x dot. So we can easily use the conservation of energy, and what will be this? So for this particular m2, when it is going to push x distance, then what will be how this thing is related to x dot. So we can easily go for conservation of energy. So this value is equal to half m, or that is m2 x dot square is equal to half k x square. So from here we can easily have x dot is equal to root under k upon m2 into x. So this is my x dot. So now we can put the value of x dot here. So when we will put this particular value of x dot, then we have xcm dot is equal to minus m2 m1 plus m2, and this value is equal to root under k upon m2. And when you are going to calculate this particular thing, then your answer will be exactly, you can just see x center of mass dot is equal to minus root under m2 into k by m1 plus m2 into x. Hence we are talking about the speed, so we have to take the magnitude, and this is your option number C is the correct option. So it's a very straightforward question, but yes, you have to understand the concept of center of mass and how its speed is going to change and whether its speed is going to constant. Hence this spring force is a conservative force, then obviously you can use this concept that your center of mass will always move with the constant speed or constant momentum. So students, this is a wonderful question. You have to try with yourself. Thank you.